So this video is the last video on ions and the periodic table, and we are going to go through the memorandum of the project on ions that I gave you. And here in front of you is what your periodic table should look like, but the periodic table of the ions and not just the atoms of the elements. So all group 1 elements, that would be hydrogen, that would be lithium, that would be sodium, and that would be potassium, should have a net +1 charge. And we are going to look at these ions in more detail just now. All group 2 should have +2. All group 3 ions should be +3. No ions for group 4s. Group 5s should have a -3. Group 6s -2. Group 7s -1. And group 8s shouldn't have ions because their outer energy levels are full. So we're now going to go and look at the groups more closely. So looking at group 1, we see that the hydrogen ion has only a proton, and there is one proton but no electrons because it's lost one electron, and so it's formed a +1. Lithium has got an inner energy level that is full. The outer electron that was in energy level 2 has been lost. You can just flip your card and see what the original atom looked like. All these elements in group 1 lose one electron. They also lose an energy level, and therefore the outermost energy level now becomes the next innermost energy level. But that energy level is full. So for lithium, it's lithium ion, its outer energy level is energy level 1, whereas for the lithium atom it was energy level 2, which was the outer energy level. But with that electron being lost, in order to have an outer energy level full, we now are left with only energy level 1 for the lithium ion. For the sodium ion, we have the same net charge +1, but we have 2 energy levels, and for the K+1 ion we have 3 energy levels, and each of these atoms in the first group loses 1 electron, so that there's one more proton than there are electrons in the atom. So let's just look at the potassium ion, for instance. If we go to the potassium ion, we see now that if we count the number of electrons, we have 2 in the first energy level, we have 8 in the second, that makes 2 + 8 is 10, we have 8 in the third, so 2 + 8 is 10 + 8 is 18 electrons, but there are 19 protons in the nucleus. So there are 19 positives and only 18 negatives, which means there's one more positive than negatives. So therefore the net or the resulting charge of the ion is +1. Let's now move to group 2. We see in group 2, if we go to group 2 now, we see here, group 2 should all be +2 charges. So we see they should be +2. And if we go and look more closely, we'll see that they also have as their outer energy level the next inner energy level. So beryllium, if you look at the beryllium atom, it had 2 valence electrons in the outer energy level. It's lost those 2 electrons, so it's also lost the outer energy level, and so the outermost energy level now is energy level 1, which is full. For magnesium, what has happened is it has lost its 2 outermost electrons, and therefore it now has only 2 energy levels, but those 2 energy levels are full. And if we look at calcium, we find that calcium would have had 2 electrons in its outermost energy level 4 as an atom, but it's lost those 2 electrons, and so its outer energy level now is energy level 3. And so let's just look at the balance between electrons and protons. It has 20 protons in the nucleus, When forming ions, nothing changes in the nucleus. The amount of protons and the amount of neutrons stays the same. But if we count here, we see we've got 2 electrons, plus 8 is 10, plus another 8 is 18. But there are 20 protons, so there's 20 pluses, 20 positive charges, and only 18 negatives, so there's a surplus of plus 2. So using this, you can check your cards, and I asked you to do your diagrams, your Bohr diagrams of the ions in pencil. So if you have made a mistake, that's fine. It's cool to make mistakes in science. Remember that catchword, it's cool to make mistakes in science because it means you're trying, eh? We can only learn if we try. So in energy level, in group 3, the group 3 atoms lose 3 electrons in order to form plus 3 ions, as we see there. And if we go closer, you can use these diagrams to check your own cards. And if you've made a mistake, just rub out whatever your mistake was and then redo it in pen. So now, if we look here, we see that the outer energy levels are the same for a period, and we see that the electron structure looks much the same. But here it's lost 3 electrons, so it's only got 2 electrons, but 5 protons, so 5 pluses, 2 negatives means it's a surplus of plus 3. The same for aluminium, but of course the aluminium ion will have 1 more full energy level than what boron will. So now let's look at the next group. Let's look at group 4. Group 4 atoms don't form ions because of the fact that in group 4 they have 4 valence electrons, and the amount of energy required to lose 4 electrons or to gain 4 electrons is too much. So these elements, rather than forming ions in order to bond or connect with another atom or ion, they choose to rather share electrons with other atoms to form what we will eventually call a covalent bond than to form ions in order to bond, because it's more energy efficient. It takes less energy to share than to completely transfer to another atom. So let's look at group 5. We see group 5. Yeah, now it's different because now we're in the non-metals, and the non-metals, as soon as you cross over to group 4, now it costs more energy to remove electrons than to gain electrons to fill the outer energy level. So therefore these gain 3 electrons because a nitrogen atom has 5 electrons in its outer energy level, so it now gains 3 electrons. And in gaining 3 electrons, it fills the outer energy level. And unlike with metals, when forming ions here, the energy levels are not, it doesn't lose an outer energy level. The outer energy level still stays the same. It's still energy level 2. Nitrogen's outer energy level for the atom is energy level 2. For the nitride ion, it's also energy level 2 because instead of losing electrons and losing an energy level, it just gains electrons in that energy level. So let's look here. 1, 2 in energy level 1, energy level 2, 1, 2, 3, 4, 5, 6, 7, 8. 2 plus 8 is 10. And we have 7 protons. So 7 positive charges and 10 negatives means there are 3 negatives in surplus. So the nitride ion or the nitrogen ion has a net charge of -3. Remember that when we deal with non-metal ions, we don't call it the nitrogen ion, we add the IDE, nitride ion. And so if we look at the phosphide ion, it will also have a -3 charge, but it will have 1 more energy level because it's in a lower period. All right, we see that if we look at where phosphorus is, if we look in that direction, it's in period 3, so it's got 3 energy levels. The outer energy level is full because 3 electrons have come from another atom, adding to the 5 valence electrons in the phosphorus atom. making it now a phosphide ion with a -3 charge. Let's just take a look. It's got 2 electrons in the first, 8 in the second, 8 in the third. So 2 plus 8 is 10, plus 8 is 18 electrons, but only 15 protons. So it's 15 positive charges, 18 negative charges. There's a surplus of 3 negative charges. So the net charge is -3. Let's now move to the next group, group 6. We should have all these ions should have a -2 charge. So let's just take a look at them. If we look at oxygen, oxygen's in period 2, so it should have 2 energy levels. It's in group 6, so it should normally have 6 valence electrons. You can just flip your card and check. I suggest you do that. But now to fill the outer energy level 2, it gains 2 electrons. Let's just check. 2 plus 8 is 10 electrons, 8 protons, 8 positives, 10 negatives means there are 2 negatives surplus. So it's got a -2 charge. We don't call it an oxygen ion because it's a non-metal. We call it an oxide ion. And the same is true if we go down and we go to sulfur. Sulfur will just have 1 more energy level and another 8 electrons because it is also in group 6. So it has, normally if you flip the card, it has 6 valence electrons in energy level 3. It gains 2 to fill the outer energy level, so it has a surplus of 2 electrons. Always count your positives and your negatives. 16 positives and 2 plus 8 is 10, plus 8 is 18. 18 negatives, 16 positives means there's 2 negative surplus, and that's what it should be. This is a sulfide ion, so I left that out here. That's a sulfide ion. This is S-2. So this should have here, we should have it here as a sulfide ion. Right, now we go to the next group. We're going to move now to the group 7. Now group 7 should have all -1 charges for the ions. Obviously the atoms are neutral, but we're not talking about atoms now, we're talking about the ions of the atoms. And the difference between an ion and an atom, as you will see, is that we've either added or taken electrons away from the atom in order to have a complete full outer energy level. So if we look here, we go in here, fluorine normally has 7 electrons in the outer energy level, but now it just gains 1. And so in doing that, we see we've got 2 plus 8, 2 electrons plus 8 is 10 electrons, 9 protons, 9 positives, 10 negatives means there's 1 negative surplus. So this is a -1 net charge. This is a fluoride ion. If we now move down to chloride, if we go to chloride, we see the chloride ion. It looks a bit more complicated, but chlorine sits in group 7, but period 3, so it's got 3 energy levels, energy level 1, 2 and 3. It gains an electron, whichever one there. There's one that's come from another atom, invariably a metal atom from the other side of the periodic table. And so we have 2 plus 8 plus 8 gives us 18 negatives, 18 electrons, but only 17 protons. So there's a net charge of -1 because there's 1 electron more than protons. If we now move to the last group, which we'll look at in the next slide. So here we see that there'll be no charge, and the reason for this is if you flip these cards, you will see that the atoms, the helium atom has 2 electrons in its outer energy level, which is energy level 1. So there's no need to take in or give away electrons. Its outer energy level is full. The same is true of neon. Neon will have a full outer energy level. Energy level 2 will have 8. Argon, energy level 3 will have 8. And so we can see that these atoms have no need to gain or lose electrons. They also have no need to share electrons. So what we find with these atoms, of these elements, is they are like bachelors. or someone who doesn't want to get married, or someone who doesn't want to partner with someone else because they are quite happy being on their own. And therefore, by the way, I must be gender specific. I think the opposite of not the opposite, the female version of a bachelor is a spinster, if I'm not mistaken. So atoms don't have gender, so I must be gender sensitive. But in essence, I hope you get the idea that these atoms have no desire to bond with any other atom. So therefore they are non-reactive. They are therefore referred to as the inert gas. Inerting means not reactive chemically. So now we've gone through all 8 of these 8 groups, the first 20 elements, ions, and so you should now have marked your periodic table of ions up to this point in the video. So what we're going to do now, we're going to summarize and end off this section. So this is the standard periodic table we give to learners at Parklands, whether you're in grade 8, 9, 10, 11 or 12. You will always get this periodic table when you are doing a chemistry test or exam. It will not change. It will be like this. You are welcome when you get your periodic table to put +1, +2, +3, 0, -3, -2, -1, 0. You're welcome to also put this little step here. Remember that this boundary here is an imaginary boundary. All the elements to the left are metals, and metals tend to give off electrons, and so this is really important. Metals lose electrons, and to form positive ions. All right, where they have the number of protons is bigger than the number of electrons because they have lost electrons. So that is true for the elements on this side of this boundary between metals and non-metals. Now let's look at the non-metals. So if we look at the non-metals, which are on this side, non-metals gain electrons to form negative ions, where the number of electrons is now greater than the number of protons. So your periodic table is really your map or your guide to help you when you write tests and exams. These definitions you need to learn for tests and exams. So just to revise these concepts, ions are atoms that have a net charge due to them having gained or lost electrons. So in a test or an exam, the mark allocation for this is usually 2 marks. So the first part is atoms that have a net charge, that would be assigned a mark, and then the second mark would have been for having gained or lost electrons. The second definition is that cations are positive ions. They are positive ions that are formed through the loss of electrons by an atom. So when later on in the year, when we do electrochemistry and we have a beaker, and in that beaker we have carbon electrodes which we charge with an external battery, so that this is positive and that is negative, because carbon graphite is a conductor, and we put in a salt solution, like for instance table salt. Then what we find is that the positive ions are attracted to the negative electrode. So they go in that direction because that electrode has got a surplus of electrons on it from the battery, from the cell. Remember, a cell is a single unit, a battery is a collection of them. Alright, so there's a surplus of negative charge here, so this positive ion gets attracted to the negative electrode. That negative electrode is called the cathode. And therefore, the positive ions are called cations because the positive ions are attracted to the cathode. See the CAT? Cations. Cations are ions that are attracted to the cathode. But the cathode is negative, which means that the ions attracted to the cathode must be positive. Therefore, cations are positive ions. Now, the reverse is true for anions. If we look at the positive electrode has got a shortage of electrons in it. So what happens is the negative ions are attracted to the positive electrode. But the positive electrode in electrochemistry is known as the anode. So the anions are the negative ions that are formed through the gain of electrons. So negative ions are attracted to the positive electrode, and therefore the negative ions are called anions. I think you see the AN. All right, and so you'll learn more about this when we do electrolysis later on in the year, but this is an indication. This is explained to you here just so that you understand why we call negative ions anions and positive ions cations. But these three definitions you need to learn for tests and exams. So let's look at the first example. It's the type of question you will get in your test that's coming up in a few weeks' time. So draw a fully labeled Bohr diagram of a calcium ion. Okay, so step one, we want to develop a method that we want to just revise. We've done this. You've done the first 20 elements ions, the Bohr diagrams of them. But let's just revise. Let's just set up a formal method. So step one, determine the charge of the ion by looking at which group the element is in. So calcium is in group 2, so it's +2. Remember, we are using the Roman numerals. So calcium occurs here. There is calcium, so calcium's in group 2. So it's going to have a +2 charge, which means it loses 2 electrons. Therefore, if we look at the number of protons and the electrons, we know that the neutrons are going to be 40 minus 20. Get that out of the way. The protons is going to be 20 from our atomic number, and the electrons is going to be 20. But wait a minute, it's lost 2 electrons. So 20 minus 2 is 18 electrons. Remember the magic numbers. We've got 2, 8, 8, 2. So therefore, if you see the number 2, 2 plus 8 is 10, 10 plus 8 is 18. Right, then we know that we're dealing with an amount where the electrons are filling their energy levels. You've got to be careful of energy level 4, because those 2 electrons don't fill energy level 4. Energy level 4 requires a lot more electrons, but we only go up to calcium. So when you see, for instance, 20, it's actually got to lose 2 electrons to get to 18, which is what's happened here. So now, if we now move on and we look at the second step, we now draw the ion by populating the energy levels with the correct number of electrons. Now, populating means to fill. It's as simple as that. It's a fancy word for filling. So don't get thrown by that. So we've got 20 protons. We've got 20 neutrons, that's the nucleus. Remember, they said a completely labeled Bohr diagram. So we've got to add the labels, nucleus, that would give us 1 mark. Label the proton, that would be another mark. Label the neutron, that would be another mark. And you would need to obviously point with a line to the neutrons and the protons. The energy level, you're going to label the energy level, that's going to give another mark. You're going to label the electron. So those are the labels. Now, you can also put the title here, the calcium ion, if you want to. You could also put calcium ion Bohr diagram. It's normally good to put in a title. Right, I know in life science they are particularly fussy about that. We are less so in physical science. Now, how many electrons does this ion have? Well, we said it's 18, eh? So let's take a look. Let's count. We say the first energy level, we draw a circle for the first energy level, put 2 electrons in. We draw a circle for the second energy level, put 8 electrons in. 2 plus 8 is 10. Draw the third energy level, represented with a circle, and the remaining, we've got 10, 2 plus 8 is 10. We need another 8. And so, yes, an ion should always have a full outer energy level. And that energy level 3 is full. One last thing I would like you to do is I would like you to put the charge here, plus 2. And now you have your completed diagram. The electrons, as you have placed them, will also get marks. So for the amount of electrons that you've put in, you will get, for the 18 electrons, you will get 2 marks. You will get a mark for each of the quantities of the protons and the neutrons. You would also get a mark for explicitly labeling or giving the symbol for each of the energy levels. And so if you add this all up, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would probably be about 10 marks. We probably wouldn't give a mark for that. So we'd be looking at anywhere between 8 and 10 marks. Sometimes what we do in exams is we then give half marks here and then we make it out of 5. But for your first test, it'll probably be out of 10, a problem like this. Let's look at the last example. The last example of this video is to draw a fully labeled Bohr diagram of a chloride ion. Now, chloride ion is an ion that is in group 7. Remember, earlier in the video, we found chlorine group 7, and we find that here on your periodic table, it would say 35.5, which has a meaning which we'll learn about in the next video, on the next subtopic, which will be ions. So we round it up to 36, because you can't get 0.5 of a neutron. So therefore, if we look at step 1 here, determine the charge of the ion by looking at which group the element is in. It's in group 7, so it's going to have, in group 7, it's going to have a -1 charge. So therefore we say, okay, well that means if it has a -1 charge, it means it's gained 1 electron. So when we look at the number of protons are 17, the number of electrons in the atom would be 17, but now it's gained 1 electron. Remember the magic numbers, 2, 10, 18, this is a magic number. The 18 is telling you that by gaining that electron, you're filling the outer energy level. So therefore, we have that's a correct amount of electrons. We look at the number of neutrons. We take the mass number minus the atomic number, the big number minus the small number, and that's 36 minus 17, which is 19. So we see in a negative ion, the number of protons, 17, is less than the number of electrons. That's why it has a net or resultant negative charge. So now we draw the ion by populating, filling the energy levels with the correct number of electrons. We have 17 protons, 19 neutrons. We got that from the previous slide. We have put in the appropriate labels: neutron, proton, nucleus, energy level. We've also assigned symbols for each of the energy levels. You need to put that in. the electron, we've put a label to an electron. You could have done it to any one of the electrons. And we see that we've got 2, we've got 10, we've got 18, but we've only got 17 protons, so therefore it's correct. What we need to do is we need to put in here that this is a -1 ion. And voila, there is your fully labeled Bohr diagram of a chloride ion. So let's just look at the mark allocation again. 1 mark for each of those. 1 mark for each of the quantities. For the amount of electrons, probably 2. And for the 3 symbols for the energy level, 1. So we're looking anywhere between 8 and 10, depending upon how we set it up. But what the point is that you need to make sure that you put all the labels in, all the quantities in, so that you don't lose marks, because these Bohr diagrams count a lot of marks in tests and exams. So now, just note this, that even though the calcium +2 ion and the chloride -1 ions have the same number of electrons, they are different ions because they have a different number of protons and neutrons, and therefore have different charges. So one's got to be very careful. If you go and you look at your cards, you will see that a lot of the ions, especially in a period, especially on the non-metal side, they will have very similar looking Bohr diagrams. And on the metal side, in a period, they'll have very similar Bohr diagrams. But they are not the same type of atom, because what determines the type of atom? Well, that's the proton number or the atomic number. It's the number of protons that determines what type of element it is, what type of atom it is. So the fact here is the protons being 17 protons, that means that this is a chlorine atom. Because we've added an electron, it's a chloride ion, but the actual atom, the nucleus hasn't changed. It's still the nucleus of a chlorine atom, albeit that we've added an electron. So now that we've done this, we have completed this section on ions, and we are now going to move on to the next subtopic, which is going to be isotopes.